Trees are incredible. They give us shade, clean our air, and make our neighborhoods beautiful. But did you know that when they're planted too close to our homes, the real danger isn't what you see above ground? The true problem lies hidden, deep beneath the surface. In this video, we're going to dig into the science of how tree roots can affect buildings. We'll explore how tree roots interact with soil, why this can cause buildings to crack and settle, and which types of soil are most at risk. We'll also look at how engineers diagnose the problem and, most importantly, how you can prevent this damage from ever happening in the first place. So, if you have a beautiful, large tree near your property, this is a video you won't want to miss. Let's get started. First, let's clear up a common misconception about how tree roots grow. Many people imagine them growing straight down, like a carrot, but that's not how it works at all. Tree roots are opportunistic explorers, spreading far and wide in their search for water and nutrients. In fact, the root system of a tree can extend to 2-3 times its height. So, a 15-meter tall tree could have roots stretching out 30 to 45 meters in every direction. These roots don't respect property lines, they follow paths of moisture. The larger and more mature the tree, the more aggressive and fast-growing its root system becomes. This means that even if a tree seems to be a safe distance away from your home, its roots might already be silently extending beneath your foundation, setting the stage for future problems. Now, let's talk about the specific impact of these roots, especially from fast-growing trees. Trees like willows, poplars, and oaks are incredibly thirsty, absorbing huge amounts of water from the soil every single day. When their roots draw moisture out of the ground, something significant happens. The soil volume decreases. Think of it like a sponge. When it's full of water, it's plump. When you squeeze the water out, it shrinks. The same thing happens to the soil beneath your house. But this shrinking doesn't happen uniformly. It creates pockets of drier, denser soil, causing the ground to settle unevenly. This is what engineers call differential settlement. As one part of your foundation sinks more than another, immense stress is placed on the structure. This leads to telltale signs like diagonal cracks spreading across your walls, floors that become uneven, and a general distortion of the building's frame. The most dangerous part is that this process happens very slowly, over months or even years, making it easy to ignore until serious structural damage has already occurred. The risk of this happening isn't the same everywhere. The type of soil your house is built on plays a massive role, and one soil type is particularly vulnerable: clay. Clay soils are a major concern for structural engineers because of their unique properties. When clay is wet, it expands significantly. When it dries out, it shrinks dramatically. Now, imagine a large tree with its root system penetrating deep into that clay soil. As the roots absorb water, they cause the clay to dry out and shrink. This shrinkage drastically reduces the soil's bearing capacity, meaning it can no longer support the weight of the foundation as effectively. The ground loses its strength, and shallow foundations, which are common in many residential buildings, begin to move. This movement is the direct cause of major structural issues, like foundation cracking, doors, and windows that suddenly jam or won't close properly, and even damage to underground service pipes for water and gas. If your home is built on clay soil, the presence of large trees nearby is a significant risk factor that needs to be taken seriously. Another common myth is that tree roots only affect the top layer of soil. This couldn't be further from the truth. While many fine, feeder roots are near the surface, the main structural roots of a large tree can go much, much deeper. They are capable of extracting moisture from depths of up to 6 meters, or nearly 20 feet. That's deep enough to affect the soil layers well below your building's foundation. This deep moisture extraction is why the damage can be so persistent. Even during extended dry seasons when the surface soil is parched, these deep roots can continue to pull water from the stable soil layers supporting your home. This also explains a puzzling phenomenon: why a building can suddenly start showing signs of cracking and settlement years after it was constructed. A tree that was small and harmless when the house was built can grow over a decade, its roots reaching deep under the foundation and only then begin to cause problems. So, how can you tell if the cracks in your walls are caused by tree roots and not something else? There are a few key warning signs that strongly point to tree-related soil shrinkage. The most significant clue is seasonal movement. Do the cracks in your walls seem to get wider during long, dry spells in the summer and then close up slightly after heavy rains or during the wet winter months? This cyclical movement is a classic indicator. The cracks widen as the tree roots dry out the soil, causing it to shrink, and then they partially close as the soil rehydrates and swells. You should also pay attention to the location of the cracks. Are they more prominent on the side of the house closest to large trees or dense vegetation? Uneven settlement patterns, where one corner of the building seems to be sinking more than others, also align with the localized effect of a tree's root system. If you're observing these seasonal changes, it's a strong signal that tree roots are likely the culprit. However, before you grab a chainsaw, it's crucial to confirm the cause. Blaming the nearest tree without a proper diagnosis can lead to costly mistakes. This is where a professional site investigation by a structural or geotechnical engineer becomes essential. A thorough investigation involves several steps. First, they will identify the tree species, its age, and its typical growth rate, as some trees are far more problematic than others. They will measure the exact distance of the tree from the building's foundations. Next, they'll take soil samples to determine the soil type, especially to see if it's a shrinkable clay. They lines also measure the moisture content of the soil at various depths and locations to map out where water is being extracted. Finally, they may install monitoring devices to track crack movements over several seasons. Only after gathering all this data can an engineer confidently confirm whether the tree is the root cause of the problem. This scientific approach ensures that any solution is based on facts, not guesswork. Once the cause is confirmed, what can be done? Fortunately, there are several effective prevention strategies and engineering solutions. The best approach is always prevention. When planning new construction or landscaping, make sure to plant large trees at a safe distance from foundations. The further, the better. In areas with clay soils, using deeper foundations, like piled foundations, can place the building's weight on more stable ground, far below the zone of root influence. For existing properties, installing a root barrier can be a very effective solution. This involves digging a deep trench between the tree and the building and installing a special membrane that blocks root growth without harming the tree. Improving drainage around your foundation can also help maintain consistent soil moisture. And what about the tree itself? Controlled management, like professional pruning to reduce its water demand, can help. But here's a critical warning. Suddenly cutting down a large, mature tree can be a disaster. The roots will stop drawing water, causing the desiccated clay soil to rapidly swell. This soil heave can cause even more severe upward movement and damage to the foundation. In conclusion, trees are not the enemy of our buildings. Poor planning, a lack of understanding of soil mechanics, and reactive rather than proactive measures are the real problems. By understanding how tree roots grow, how they interact with different soil types, and the importance of proper foundation design, we can create a built environment that exists in harmony with nature. Ensuring the long-term safety of our homes requires us to look below the surface and appreciate the powerful, hidden forces at play. It's all about building smarter, not clearing our green spaces. If you found this video helpful and want to learn more about civil engineering and the world around us, please give it a like, share it with others who might find it useful, and subscribe to our channel for more content like this. Thanks for watching.